Hello everyone, in this video I'm going to explain to you the minor project part, which is going to be about the engine block. Now the engine block is the main body of any engine. It consists of the cylinder, which is going to hold the piston inside, where the piston is going to move up and down in the internal combustion engine, compress the mixture of the air and the fuel. You're going to have the explosion having due to the present of the spark from the spark plug, or maybe just due to the high pressure we're going to have in the diesel engine, and then we're going to have the explosion and we're going to have the expansion. So during this process, the piston will go up and down at very high temperature, very high pressure, and this should be contained in the cylinder, which is going to consist of metal, which can hold this pressure and resist the changes in the temperature during the operation. This engine block example is from a Vector. Vector is a company which making the engine block, this single cylinder engine block, which is going to have the two-stroke engines. Two-stroke engine that we don't have with the valve. But instead of that, we're going to have the opening to the side at two different levels. That's going to cause the feeding from the carburetor and exhaust of the gas and the explosion process. This engine block has been made by a process which is called the cast iron. Sorry, the material is cast iron. The process is called the casting. And the casting, and later when you come to the lab, you will check that the surface of this casting is too rough. That's because it's made of a casting process which is called the sand casting. The roughness came from the wall of the cast mold is made of the sand, and that's what caused the cavities to appear here. Later we're going to explain that the mold of the casting in the sand casting is going to consist of two halves, and this two halves would cause the line in the middle of the product we're going to have. Now later we're going to explain to you the process of the casting, and you will see that the complicated shapes is going to be made by the easiest method of the casting, which is the sand casting, the process that the human have been used for thousands of years. Because we can shape the mold from the sand to a very complicated shapes, and then we can destroy to take the parts. So we don't have to think about how to open the mold after the product is going to be solidified. So gray cast iron is the material. Again, to melt the cast iron, and we are going to take it to the higher temperature. Is going to be called the pouring temperature to make it more soluble. We are going to fill the cavity of the mold with the liquid metal, fill all the cavities, then leave it to solidify. When we are going to be sure that the part has been solidified, and this actually going to be done by calculating the time experimentally, then we are going to, depending of course on the size and the volume and the surface area, and then we are going to break the mold, take off all the sand, clean the part, and then take it to the next step, which is going to be the testing. During the testing, we are going to look at the part visually, and we are going to see if we are going to have some missing parts caused by the non-complete filling of the cavities inside the mold. Or we may have some bubbles because some of the gas could not, because when you burn something and you melt it, water or metal, are going to have some gas released. If this gas release cannot find its way through the mold wall to the outside, it will be trapped. And these trapped gases will cause the cavities to appear on the surface. These are all disadvantages of the casting process, and we are going to learn later how we can avoid these disadvantages. So we take the part from the mold out with casting, and we need to do a machining on it. This machining will include the preparing of the surfaces and to achieve the good surface finishing for the piston, for example. Prepare some of the edges. Prepare the surface finishing here for the bearing to be sitting on. Now we are going to have multiple machining processes to do that. The first process is going to be, for example, the face milling. We call it the face milling because the cutting tool is going to cut a face to prepare a new face. We're going to have a good surface finishing and levelized. Because usually the casting is not going to give you a perfect surface. So face milling is going to be the first one. Second one, we can do the boring process. The boring process is something similar to the drilling operation, but instead of creating the hole, we're going to enlarge the hole by the boring process. Now you'll say, okay, now why we are enlarging the hole? Because during the operation of the casting, we can create the pre-holes by putting something inside. This can be a dried sand. Okay, cylindrical shape of the sand we can put in. And then we can remove it when we finish the casting process. So it's going to have a pre-hole, not to the size, not to good surface finishing, and then we can do the finishing on by using the boring. The boring will give us a good dimensions, but not good surface finishing. So later we can do another operation which is called the hopping, and the hopping operation will simply get to generate the good surface finishing required. The most important thing that in the internal combustion engine we need to have a continuous lubrication. Not only lubrication, but also we need to have the walls to have the like what they call, they should hold some of the lubricant inside while the piston going up and down. To do that, the honing operation is going to make the close shape of the surface inside. So actually you can see that by the microscope, not by hand. But if I get to feel it with my nails, it's going to be quite good. Another operation we can do after we prepare the face, we prepare the internal cavity, is drilling and tapping. We also need to prepare these holes to the side because this will be a mating part to close the engine block to have the complete engine. So these are some critical points because this should be meeting the other sides of the engine block. Otherwise, we're not going to be able to close it and get the required pressure sealing from the sides. Critical points, another critical point here, which is going to be the surface. The levelness of the surface, otherwise the head of the engine is not going to be sealing the pressure inside the piston. Another point is going to be the drilling location of these holes and the tapping of the thread inside. By that, we're finishing the thing and we can test it. Now I talked something about the testing process. So it was visually just to see the thing, that if that's going to be outside, what will be the case? We're going to have the bubble straps inside. So we have another method, which can be either the destruction method, that's mean I need to break one of the samples I made and check if we're going to have some deficiencies inside or defects inside. Or simply I can bring a hammer and start to knock it on multiple places. Or in more advanced process, I can simply using something like the X-ray to check if I can have any cavities, bubbles inside. So that's how to make the engine block and how to finish the engine block. This process is actually going to be near net shape. That's mean the casting almost done the shape, but the machining need to finish the other steps to get the final shape of the part. So just remember these terms: the sand casting, the core to make the internal hole pre to the machining process. Remember the term of face milling, the bore process, the honing process, the drilling and the tapping, and of course the other types of the testing we applied for this product. Thank you for your listening and hope to see you soon.